when you do this question, you need some informations here about the springs, compression, and stretch. The two blocks are connected here, A and B. Initially, this block is moving with the velocity and this block is at rest. So before its motion, before this block A is get collide with block B, only the object A is moving. At this time, this will compress the maximum. Maximum compression will be there. That is before motion of these two objects. In this question, they say the maximum compression of the spring during the motion. Okay, which means the block A is collide with block B and both of them are moving in the same direction. When they are moving in the same direction, this maximum compression is possible only if these two blocks moving at a constant speed or the same speed. Okay, if block B moves faster than block A, what will happen? There will not be a compression, there will be a stretch. So they are not asking maximum stretch, okay, they are asking maximum compression. Maximum compression is possible only when these two objects are moving at a same speed. So that is very important key point in this question. Okay, so maximum compression is possible only if these two objects are moving at a constant speed. Otherwise, I told you there will be a stretching. Okay, the B object move faster than the block A, then there will be a stretching. So they ask maximum compression. So these two blocks should have the same speed, then you will get a maximum compression. Okay, this is a key point 1. Now what is the key point 2? Here we are using the conservation of momentum. Using this, we will find the velocity of these two blocks after collision. And number 3, we are using conservation of energy. From this, we will be finding the maximum compression X we will be finding. Okay, so you should know the conservation of momentum information, that is momentum before collision, that is initial momentum is equal to final momentum. Initial momentum of the two blocks, final momentum of the two blocks are equal. When you equal, you can find the final velocity, which means the velocity of A and B together. Okay, as I mentioned, after collision, the velocity must be constant, same speed. Okay, so there won't be VA and VB. Those two velocities are equal. Okay, VA and VB are equal, so we can write V there. Okay, let's begin with the conservation of momentum. Conservation of momentum, that is initial momentum is equal to final momentum. What is the initial momentum? The two blocks, it has 2 kilogram and the block B 3 kilogram and the speed 0.15 meter per second, and here speed is 0. So initial momentum will be like this, MA VA plus MB VB is equal to final momentum. MA final momentum is V. As I told you before, the constant speed. This is MB V. So here the V is constant. So MA plus MB. Here you can apply the values. This will be 0 because it is at rest before collision, it was at rest. So this term 0. Here you have mass A and the velocity A. Mass A, velocity A is given. How much? 2 times 0.15, and we have to find mass A and mass B value is here. How much? 5. 2 plus 3, 5. And if you multiply 0.3 and the 5 will go to the denominator and we can find V is equal to 0.06 meter per second. So from momentum concept, principle of law of conservation of momentum, we found the velocity value 0.06 meter per second. Now what is our target? Our target is to find the compression, maximum compression. Same concept, conservation of energy. Conservation of energy means the total energy remains constant before motion and after motion. So initial total energy is equal to final total energy. It means before it the begins collision and after collision, the total energies are the same. Okay. So before collision, the two objects will have the kinetic and potential energy. So the potential energy of the first object is 0. Second object is also 0 because it is on the ground. The two objects are located on the ground. So when it is on the ground, potential energy is 0. And there is no extension or compression in the spring at the before it start during the motion. So the stored energy of the spring also 0. Only it has the kinetic energy. So the kinetic energy of the first object is half mv square. We can write it. So half mv square. And for the second object, there is no kinetic energy, there is no potential energy, so 0. After collision, the first object is moving, so it has the kinetic energy. V will be v square. No VA, VB, same speed. Second object, MB, v square. Now extra one energy is there, that is the compression. As two objects are moving, blocks are moving, the spring gets compressed, so it has the stored energy, potential energy. The formula is K half kx square. Now you can cancel all the halves and fuse all the values. This MAVA square, MA is 2. Write all the values. The MAV square, mass of the first object, first block 2, VA square 0.15 square, and MA here again 2, and MB here 3. V square you can take common. V square is 0.06 square plus K value 10.8 x square. So you can find 2 times 0.15 square minus this 5 times 0.06 square is equal to 10.8 x square. So 10.8 x square is equal to 2 times 0.15 square minus 5 times 0.06 square. Then this divided by 10.8. So if you take the whole square root, all the values, you will get 0.05 meter.